Today we are doing the Pendulum lab, and we are going to do 4 different experiments. The first one being the effect of weight on a pendulum. I have an ornament, a rubber ball, and a key. So we're going to test to see if the weight affects the pendulum. The second one, we're going to see if the amplitude affects the pendulum. We're going to do all those experiments with the rubber ball, just to keep it all even. And then for the third, we're going to do effective length on a pendulum. We're going to continue using the rubber ball, and I have some shorter strings to test with. And then for the last one, it is going to be the pendulum and acceleration due to gravity. So we'll go ahead and count those there at the end. So first things first, I'm going to set up my pendulum, and we are going to test the effective weight on the pendulum. So for my first item, I have a ornament on the end of my 100cm string, and I'm going to drop it from a 15cm amplitude, and I'm going to see how many swings it has, cycles it has in a minute. Ready? It had 29 cycles in a minute. We are going to go ahead and test it again from the same amplitude for a minute. It had 29 cycles in a minute. We are going to do trial 3. We are going to drop it from the same 15cm. It had 29 cycles in a minute. All 3 trials had 29 cycles, making it an average of 29 cycles per minute. For my next object, I have my key hanging from the ceiling on my 100cm string. I'm going to drop it from a 15cm incline, and I'm going to count how many cycles it has per minute. So it had 30 cycles in 1 minute. I'm going to drop it from the same 15-degree height for trial number 2. This one had 29 cycles in 1 minute. We are going to do trial number 3. This third trial had 29 cycles in 1 minute, which made trial 1 30 cycles, trial 2 29 cycles, and trial 3 29 cycles, for an average of 29.3 cycles per minute with all 3 trials. For my third and final object, I have my rubber ball hanging from the ceiling on my 100cm string, and I'm going to drop it from a 15-degree angle to see how many cycles it passes in a minute. So I'm going to go ahead and pray it doesn't fall off. Okay. I had 29 cycles in 1 minute. I'm going to go ahead and do trial number 2 from the same. I had 28 cycles in 1 minute. We are going to go ahead and drop one last time for trial number 3. For this third trial, I had 28 swings. So I had, for trial 1, 29, for trial 2, 28, and for trial 3, 28, making it an average of 28.3. For all 3 trials, I had averages of 29.3, 28.3, and 29, meaning that the weight of a pendulum does not affect how many cycles it is going to have. For the next experiment, we are going to keep the rubber ball up here, and we are going to drop it from 3 different amplitudes. The first one is going to be, we did 15 degrees. We are going to do one from 10 and one from like 30. Using the same rubber ball for all 3. I'm going to see how many cycles it has in a minute from each level. First one we are going to do is we are going to do 10 degrees. We are going to start. For this first one, we had it at 30 sways. We're going to go ahead and do trial number 2. For this trial 2, I had 29 cycles. So I will go ahead and do trial number 3. For trial 3, I had it at 30 cycles per minute, so that makes our trial 1 30 cycles, trial 2 29 cycles, and trial 3 30 cycles, making it an average of 29.7 cycles per minute for all 3 trials. For this next one, we are going to keep the ball and we are going to drop it from a 30-degree height. Since we already have all the numbers for a 15-degree drop, I'm just going to skip right to 30. The numbers for the 15 were 29 for the first trial, 28 for the second trial, and 28 for the third trial, making it an average of 28.3 for all 3 trials. We're going to go ahead and drop from 30 degrees for trial number 1. For my first trial of 30 degrees, we ended with 29 passages or cycles. So I'm going to try for my second trial from 30 degrees. For that trial, we had 29 cycles per minute, so we are going to try trial number 3 from 30 degrees. For trial number 3, I ended with 29 cycles, meaning all 3 trials were 29 cycles, so that ended up with an average of 29 cycles per minute. So as a recap, for the 10-degree angle, we had trial 1 of 30 cycles, trial 2 of 29 cycles, and trial 3 of 30 cycles for an average of 29.7 cycles per minute. For the 30-degree trial, we had 29 for all 3 with a average of 29 cycles per minute. And for the 15-degree, we had 29 cycles for the first trial, 28 the second, and 28 the third, making it an average of 28.3. The averages of all 3 were 29.7, 29, and 28.3, meaning that the amplitude changing for a pendulum does not affect the cycles per minute. Okay, for this next experiment, we have the effect of the length of the pendulum. I have my 3 separate pendulums. I have the 100 centimeter here, this is 50, and then I have a 25 centimeter one that I just dropped and it broke, that I'm going to be testing My phone is almost out of storage for video, so I'm going to do these trials off camera and then I'm going to report back my findings. Okay, so my findings for these last two trials were the 25 centimeter string. Trial 1 was 43 swings, trial 2 was 41 swings, and trial 3 was 40 swings for an average of 41.3. My 50 centimeter string, trial 1 was 36 swings, trial 2 was 35 swings, and trial 3 was 35 swings. Then for my 100, it was 30, 29, 29, which is an average of 29.3, with all three averages being 41.3, 35.3, and 29.3. It shows that the length of the pendulum does have a direct effect on a pendulum cycles per minute. For this we have one last experiment. It is going to be acceleration due to gravity. We're going to let the pendulum swing, and I'm going to see how much time it takes for the pendulum to swing 25 times, and then I'm going to do it again for 100 full swings. And I'm going to do 3 trials of that, and then I'll be back with my findings. So I finished the final experiment of the pendulum and the acceleration due to gravity. For my first trial, I did 25 full swings. The time was 25.10 seconds. And then the time for 100 swings was 100.4 seconds, meaning that making it a period of 1 second and a square period of 1 second. Trial number 2 was 24.95 seconds for 25 swings, 99.8 seconds for 100 full swings, making it a period of 0.998 seconds and a square period of 0.996 seconds. For trial number 3, I had it at 25.20 seconds for 25 full swings and 100.8 seconds for 100 full swings, making it a period of 100.01, and a square period of 1.02. The average for 25 full swings was 25.8. The average time for 100 full swings was 100.3. The average period was 1, and the average square period was 1.01. The experimental value of G was 9.78 minute m/s squared. The theoretical value of G was 9.8 m/s squared, and the percentage error was 0.2%. My results from these experiments were that the weight of the bob does not significantly affect the period of the pendulum. The varying amplitude produced no significant change in the period for small amplitudes. The length of the pendulum had a direct effect on its period as the pendulum length increased, the period also increased. Those were the findings of my lab.